with the topic about digitalization and nature-based strategies for sustainable global agri-food supply chain system. Professor Kune-muh is attending the session on site in this room with all the participants. And the session will be led by our moderator, Ms. Intan Dewi Larasati, STP MSc. Let me read the moderator CV for you. Ms. Intan Dewi Larasati, STP MSc, is a lecturer in the Department of Food and Agricultural Product Technology, Universitas Gadjah Mada, with expertise in food quality, metabolomics, and food chemistry. She completed her master's studies at UGM and collaborative research in Spain. She has published works on advanced analytical methods for coffee classification, eco-friendly quantification of phenolic compounds in raw cell, and bioprocess strategies for kombucha fermentation. Her research emphasizes sustainable and innovative approaches to food analysis and functional product development, contributing to advancement in modern food science. Without further ado, Ms. Intan Dewi Larasati, STP MSc, the time is yours.
Hello, good morning everyone. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, and warm greeting to us all. Thank you very much for Master of Ceremony for a kind introduction. Once again, welcome everyone to this short course session. My name Intan Dewi Larasati. You can call my name Intan, and I'm a lecturer in Department of Food and Agricultural Product Technology, Universitas Gadjah Mada. And I'm very honored to be your moderator in this session. And yeah, my current research focus on food quality, metabolomics, chemometric modeling, and valorization of natural bioactive compound from food materials, especially raw cell-based product. And today, we are going to have an exciting and insightful session on the topic digitalization and nature-based strategy for sustainable global agri-food supply chain system. And this session will be delivered by Prof. Kune-muh from National Kaohsiung University of Science and Technology, Taiwan. And before we begin, it is my great pleasure to introduce our speaker. So, Prof. Kune-muh is a distinguished academic from the Department of Logistic Management, National Kaohsiung University of Science and Technology, Taiwan, and he earned his PhD in Industrial Engineering from Purdue University, United States of America. His professional background include academic leadership, logistic management, and international work in cold chain standard and supply chain management. And his expertise is highly relevant to today's session, especially in the area of supply chain, manufacturing, and sustainable supply management. We are truly honored to have him with us today. So, Prof. Tsai, it is great pleasure to have you with us today. I hope you are doing well and enjoy your time in Indonesia. How's your day?
Yeah, it's good. Yeah,
Yeah.
really good. Yeah.
Thank you very much for being here and your willingness to share your knowledge
Okay.
and insight with us. We are truly honored to have with you. So, yeah, Prof. Chai, you will deliver the presentation for about 60 minutes
Okay.
until 11:15, and will be followed with the 30-minute discussion
Yeah,
and
thanks.
Q&A session. So, guys, without further ado, I would like to invite Prof. Chai to begin the presentation.
Yeah, good morning. Yeah, thank you. Yeah, good morning, everybody. Yeah, you look young and bright and promising. Yeah, it's my great pleasure to come here. You know, I have been participating at the short section for several times, but this is the first time. But I'm here, you know, in person. But of course, for UGM, I've been here for 3 times, so it's my great pleasure. And today, our this is our topic. You know, yeah, you will know that. So I'm going to talk about either both the digitalization and also the nature-based, strategy about agriculture. So I haven't opened it.
I think a bit low from the internet.
Okay. Oh, it's slow. Okay. I go up.
I think it's a bit low from the internet.
Okay. Anyway, yeah, the first, I have some put the course into some module. The first is the broken plate. It's and today, the agriculture had come to a new era because of a new technology, and also we are looking into the ecosystem. That if agriculture can help with ecosystem instead of bring more harm to the ecosystem. So we need technology to help that. So I think that this college is pretty good. It's about agricultural technology, and this is what we need today. Right? So this is forward. Is this?
Yeah, this one. The bottom is the next one.
Okay. Okay. So usually what we ask for the fresh food, we hope that we can have food that is safe, and it can when we buy them, they can be fresh and have long shelf life, and also with reasonable price, and we can have multiple choices, and when we need something, it will be there, responsiveness. So actually, for a fresh food value chain, it's from production to handling to consumption, and we need to have a well-managed fresh food, management in order to, fulfill the need of every consumers. Right. I'm not good at handling this. And agriculture can be a sustainability driver, but if we don't do it right, it can bring a lot of harm to the environment. Yeah, because agriculture contribute to about 30% of the greenhouse gas, in totally, from farm to food. So that's considered as the largest industry, for the global warming. But if we have some ways, to reduce its impact to the environment and even contribute, so that's what we are looking into at this age. So for the agriculture, we hope that it can be efficient, okay, and we can reduce waste and also reduce the carbon footprint, and also some of the economic inclusion that we can increase the revenue of every farmers, and it can help to protect the environment, for the emission and also for the chemicals that run off to the soil, and they are quite significant for the protection of the earth. And today we are talking about precision in agriculture. So in the past we have mass irrigation, and it's a lot of loss, for the water itself. And today, and also some of the fertile, the same. And so today, it's an era of using the IoT for the monitoring and to achieve the precision in the agriculture. And so we can monitor the crop health and also the soil monitor, moisture, etc. In order to achieve, we call it the precision agriculture. Okay. And for the nature-based and sustainability strategy, as I mentioned, that from farm to food, it contributes to about 30% of the greenhouse gas. So if we can have a climate-smart agriculture, that is important. Okay, and if we can utilize renewable energy, okay, and do the circular economy, in food industry, not only in in the non-metal industry. And there are also some of the, we call it the regenerative farming. I think that if you are a niche expert, you must have known that, regenerative farming, because we want to protect the soil, and in the meantime, we can maintain the productivity and also absorb more carbon dioxide into the soils. And also organic practices. Yeah, organic practices. So organic is also a top important topic. And in this, we call it the digital sustainability framework. There are many two kinds. The first is, centralized data ecosystem. For example, the IBM Food Trust. They have integration of millions of farmers all together. Okay, and a lot of retailers, etc. And also the other is digital regulation. But for this, it's a lot of government are trying to do this. For example, you can predict the demand and the supply and try to find the balance. But a lot of time, fail, because even in Taiwan, we have too much cabbage production during the winter time, and the government set up a website that if you want to plant it, you have to register. And but when even when farmers see a lot of acre is planting, they still keep planting. Yeah, and even though they know that the price will drop, they still do that. So every year, it has been many years, the same thing. At first, we thought that if we have a website that telling everybody that right now how many acres are in production for the cabbage, the follower will stop their action, but it just keep happening every day. So that's quite an ideal, thinking that if we can have some digital platform to prevent overproduction. In Taiwan's case about cabbage, they fail. Okay. And so all these are what we call the ecosystem. One need to walk you, to have some statistics about what's going on, to try to find a balance, because for agricultural product, they cannot last longer. Okay. And we need to have a better balance between demand and supply in order to use less cold chain, to maintain the food, and at the meantime, the price for the farmer can be good. Okay, and the consumers, can be reasonable. but a lot of time they just fail. And the other is about like this, we call it a smart agriculture with IoT. Yeah, this is also one of the topic today. And today, for the precision agriculture, we need to have IoT to monitor the soil health, the environment, the soil moisture, etc., in order to have a better decision. And with all the data collected, nowadays, the AI algorithm, can help us to do all the calculation about when to irrigate, when to have some fertilizer, etc. And we can predict how much crop we can, the crop yields, So this is the system. Right now, some of the agricultural technology companies are doing. And also the traceability, traceability, blockchain is only one of the solutions for the food safety. In Taiwan, we have other systems which are easier. I will introduce you to you. And for the blockchain, the IBM food chart is one of successful, agriculture, food blockchain. And later we will talk about that because they can have some immutable tracking of the product, from farm to fork. And, it was first established in order to ensure the food safety because, food safety is always the main concern. Of course, we concern about, environment, but food safety just happened. So it's more urgent, we need to be able to trace back to, the history of the food that it might be poisonous, to some of the consumers. And in the past, in the United States, it will take them about a week to trace back one food. And if there are 10 foods, they are in, they are thinking that it could be in danger, it will take them a long time, and during that period of time, more would be in danger. But with this food chain, they can get it in a second, really in a second. You just trace back about, they say it is that in every 22 seconds, they can get all the records because every step of the food during the process from farm to fork is recorded and it is immutable. It's immutable. So, all the record is there and it is correct. Nobody can change that. And actually, there are also the big gap, for us, to adapt the high tech and also achieve the nature-based agriculture. The first is digital divide, and because of we need to have, infrastructure gaps. We need to have a technology infrastructure, and not every country in every corner have accessible infrastructure. Okay, so this is a lot of infrastructure, but for those countries who have the better infrastructure, they can really improve that. And also, this is the digital world. So even though you are in agriculture area, you are a farmer, you need to be trained about using the technology. So training is also required. Okay. And of course, there are some high setup costs. So some of the, financial plan, should be raised up, by the government, by some institutions. And of course, there are some companies, who support the financial, budget, and of course they had to cooperate with them, okay, in order to, later on we have a case that in order to sequestrate, the carbon dioxide into the soil, and they can generate a revenue out of it, okay. And of course there are some of the policy and governance by the government, okay. So all these are, important, in order we can have apply the high tech into the agriculture in each new area. And we hope that the linear food economy can be changed to like a circular economy, okay? And of course, it will always be good. And this tells you about the environmental toll of agriculture. As I mentioned, that agriculture accounts for about 30% of the global greenhouse gas. And it also consumes about 70% of the fresh water. Okay. And the topsoil will also be lost. Okay. If we do not have a proper way of having our agriculture. So these are the consequences of having a food. Yeah. So it's quite challenging. Especially today, the population keep growing, and in the SDG, zero hunger is the top priority. But still, right now, there are still about 800 million of people are still in hunger. Okay, in hunger. So there are a lot of challenges. For you, most of you are in agriculture area, so a lot of challenges. It means opportunities as well. And also the supply chain is fragile. Okay, for example, recent hormones crisis, it bring up a lot of cost. So it's going to affect the agricultural product price. So also labor shortage, okay, and geopolitical tension, they all have effect on the agriculture industry itself. This is a job point, just to give you an idea that what is happening right now, and even not even the Strait of Hormuz, but is also the Suez Canal. There was an event in 2021. A big vessel got stuck there. You might think that it's easy to move it around. No, it's not easy. It takes them about a week. And even though it got stuck for a week, about 300 vessels were affected. So the global is interconnected. One event affect the other. So today is quite challenging for you. And 20 years ago, the world is quite flat. It's quite easy. Because I'm teaching supply chain. 20 years ago, when I teach supply chain, I say, well, there's only one strategy. If you want to manufacture, go to China. That's all, because they offer the most efficient and cost-effective way of manufacturing. And today is totally different. In the past 10 years, it has been changed. Yeah, it has been changed. Yeah. So, and the food waste paradox. The first is about 1/3 of the food produced was lost or wasted. And we still have some food insecurity in terms of safety and also in terms of the volume that we can have. So the impact is if food is considered a country, it will be the third largest emitter of the greenhouse gas, food waste. So this is some of the slide about that. And so 1/3, do you know 1/3 of food, how much, what's the population we can feed for the loss of the food? Can you calculate that? In average, how much food we need a day for a year per capita? You are in agriculture area, you must know this. Do you know the statistics? How much? How much kilo of food we need for a person per capita a year? In average, a rough idea. Do you know how much we consume a year? And then we will be healthy. You are in this area, you should know this figure. Usually it's about half ton, 500 kilos. Yeah, some say it's 400 will be enough. Okay, or 300, yeah, probably maximum, no minimum. Yeah, and if you eat over 600, you are getting bigger and bigger. Yeah, yeah. So if we can convert, 1.2 billion tons of food, this was static about 10 years ago, okay, more than 10 years ago. And if we divide that actually for the food, we can feed about 3 billion of people. No, yeah, 3 billion of people for the loss of the food. So there will be no hunger at all. Yeah, if we do not have any food loss. Of course, that's impossible. That's impossible because we only like the best part of a food. We will chop off here and chop off there. Okay. And of course, after the chop off, if we can thinking of the food production, food chain, okay, and from production to consumption. We divide it into developing country and developed country. Okay, so for the developing country, the larger percentage of food waste is at the upstream. It means production, handling, blah blah blah. Okay, and they were quite efficient in the consumption, but for developed country, they waste a lot, most of their food at the consumption area. Period. So you buy too much, and you throw them away during the weekend, and you keep buying because food price is only a small portion of your living expenses, so you don't care. Yeah, so that's what happened in developed country. And in developing country, on the contrary, they are now the consumer are not so you know so wasted, but they waste more in the production and handling. It's many of agricultural technology as well as cold supply chain. We need to have a cold chain system, before or after, you harvest, post-harvest process. I know there's a specialty about this, post-harvest, but post-harvest, you have some technology, and together you had to bring it together with cold supply chain, okay, in order to have a better preservation of the food. So, food chain is considered as the third largest food loss. Yeah, yeah, it's more than India and Russia together. Yeah. So I'm going to skip this because we do not have time for this discussion, and later on we can talk about that. So, so the next module we move to is about technology part. Okay, so technology, what we mean here, some technology like IoT, blockchain, AI, etc. Okay, and we hope that we can move from opaque supply chain to a data-driven network. Okay, and to use the digital tools to optimize the logistics, reduce waste, and also create a transparency. So the problem from farm to table, we can divide it into three. Actually, there are something more, but here I'm going to talk about three that could be related to technology-based solution. The first is efficient, and we need efficiency, and also there are a lot of manpower shortage. So AIoT, can help enhance, the decision and also the automation. And the second is about, cold logistics service and also the traceability. Traceability, the IBM food chain is one of the solution, and in Taiwan we have another easier solution, to ensure the quality and safety of the food. And the third is, we at the beginning we talk about the unbalanced produce production. So we need to do the coordination between fruit and vegetables. I just mentioned about the case of Taiwan. We have the government have a website showing that how much cabbage is cultivated, but no farmer care. Okay, but if you are part of a supply chain of a company, the company will ask you to control, right? Because for the government, it's a free market. So they might not care. But if you are a supply chain, they need to have tighter control. They need the demand, and they will control the supply. Okay, and as you are one of the farmer, you will follow their regulation. Okay, their orders. Yeah, that's one of the company in Taiwan doing this, and it's quite successful in this way. So a company can do that, trust me, but not really a government. A government's figure can only be a reference. Okay. Yeah. But all the farmers, when they make decision, they will think, well, I'm not be not the I might have their own luck. Yeah. So the IoT, is quite important today, especially in agriculture. And IoT, this idea has been around for more than 20 years, but not until recently, in the past 10 years, it's been around in many of the countries because of IoT's cost is dropping. It's dropping. And do you know whom to thank to? You have to thank to everybody because we are using the cell phone. Okay. And in cell phone, there are many IoT, same technology. Okay. So, with iPhone in mass production, so the IoT's price keep dropping. And we can put in the soil, blah, 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 because the price become trivial. Not that expensive like 20 or 30 years ago. But this technology has been around. Yeah, but in order to put into use, we need to consider about the cost perspective. So like a GPS, sensor, satellite, drones, yeah, they become cheaper. We can monitor the soil moisture, nutrition level, the crop health, etc. Okay, so we can have exact application, water, fertilizer, okay, etc. And they are good. Okay, with IoT, we can have a precision agriculture. So this is like drip irrigation. Drip irrigation is quite successful technology developed by Israel. Okay, but at the beginning they didn't use AIoT, but right now, of course, they are using, and around the world, some of the countries they are using AIoT to accompany with drip irrigation. In Taiwan, we only have a small portion of drip irrigation. Most still rely on the governments. We have irrigation system. We pump water from the dam, to the field, and because it's almost free, so the farmer didn't want to change. But it consumes, a lot of our water, and it's competing, the water usage of cheap production in Taiwan. You might think it's quite ridiculous because the value of the two is quite different. Cheap is so expensive, and the food production which is so cheap, but they are competing the same resources that is water. But I don't know, Taiwan's agriculture, I always tell the government that you should change, the way of distributing the fresh water. to the industry and to agriculture. Agriculture can be, right now, it's the usage of agricultural water is about 65% in Taiwan. It's quite ridiculous. Taiwan is an industrialized country. Okay. And our living and industry only use the rest of 35%. But for the 65% of the usage, the GDP contribution is less than 5%. Quite ridiculous. And how about the farmer? Because they can vote. So it's not easy to change that. You know, as a democratic country, it's hard to change that. But I always think that irrigation can be a good solution for Taiwan. And I think that I know that no problem for Indonesia. You are raining all the time. You have abundance of water. Yeah, so there's no problem for you. But for many other countries, most other countries, water is a stringent resources, very important resources. Yeah. So agriculture, and to your astonishing, Israel exports 76% of their agricultural product to EU. So a lot of their morning seller is from Israel. It's a desert country, and they have limited water, and they supply a lot of fresh vegetable to Europe. Yeah, and their total output value is 13 billion. It's a lot of money. Small Israel. Yeah. The other country I didn't mention here, also using technology to export a lot of agricultural value, is Netherlands. You might not know that Netherlands is the second largest agricultural product export in the whole world, next to the United States. You might not know that. They are so tiny, right? But the agricultural value is the second in the whole world. More than Thailand, more than Indonesia, more than Vietnam, more than Brazil. How they do that? They use a lot of technology. And of course, they look into the high value, like tulip, okay, a lot of floral products, and also cheese. I don't know, some other. But from the statistics, it really astonished me. Yeah, yeah. So I think there are a lot to learn from. Yeah, from the Dutch people. Yeah, how they can do that. Of course, they will not teach you. Otherwise, they will have a fierce competitor. Right? You have a lot of natural advantage over Dutch in agriculture area. Yeah. Now, blockchain for the traceability. Yeah, this is the IBM. Yeah, IBM who trust blockchain. As you see, there are like 570 million growers and logistic 1.9 million. A retailer they are 33,000. They are chain stores. So imagine how large it could be. So it's quite a successful blockchain system. And to trace back, the product there, they only take average 22 seconds. So they are really good, really good. Reduce waste efficient, and to make sure it's a fair trade. Okay, and guarantee the zero deforestation, because deforestation, also causes a lot of greenhouse gas, about 30% of the whole agriculture contribution to the greenhouse gas. Okay. And in Taiwan, we have another easier, traceability food chain system. The first is we call it a T-TAP. It's a good agricultural practice. So for this, you need to register. And for every product, you will get a QR code. Not a company, but every product. So scan it, you get all the traces. Okay, it's controlled by the government. Of course, right now it's a blockchain technology. but you need to pay some money for that. Okay. And the other is what we call is easier. It's that we call it the QR code traceability system. Okay, we have both in seafood, seafood, and also for other agriculture and food product. So as you can see here, this is for agriculture product. This is for aqua product. So and this is done by also by a government, but each company got only one QR code, even though you're 10 products. Okay, but it's just like you scan it, you see the policy of the company, you can see some photo, you can put everything what you want on the website. Okay, to get the trust from from the consumers, and the government will audit once in a while. So you can believe them, but not 100%. But at least it's controlled. It's better than nothing. And this is the cost is quite trivial. Yeah. And so when you participate in this system, you don't need to pay money. And AI, what AI can do for this, AI can do, AI is more and more mature, okay? And they can do like weather prediction, demand forecast, and also the yield optimization, okay? And they can use like a machine learning to identify that if there's a crop disease, they can monitor and get data back and to see if there's a crop disease, okay, and over the smartphone, okay. So right now the technology is there, but I think that this still costs some money. And to solve the third problem, this is an example of Taiwan company. They are using supply and demand coordination here, as you can see from here. Producer and supplier, it's they are, it's the supplier of, they are like a packaging, food packaging company. Okay, and they have a lot of farmer as the supplier. And they will have tighter control over their partners, about how much to produce and what to produce. They will give them a forecast. And the forecast is based on their chain sale. So it's not a push system, it becomes a pull system. So you can forecast from your past sale and to know that, based on past experiences and, what product to produce and how much. And they will ask their producers to have a better control over this. And it's quite successful for this company. Yeah, it's quite successful. But as I mentioned, for Taiwanese government to do that, it's impossible. Yeah. So, because they want to avoid this problem, overproduction or underproduction. So it is driven by the market. So it's always the best strategy to do that. So this is the company. This is a company or the producer. They are the company I visit is this one. They are the supplier, and also they have they do the packaging. Moderating, right? Like your role, moderating. Between the producer and the logistics. Okay, and they also have a physical distribution and sell to the channel. This is their system. This is their system, and they do the coordination between the two. And this company, they also implement AI and autonomy in their warehouse. And the customer's orders will determine the delivery sequence and amount to deliver. So, in Taiwan, it's a small market. So in every truck, they will deliver the product to the agricultural produces to many retailers. And based on the route, okay, and the orders, they will have a sequence they need a sequence. Okay, and to do the truck dispatching, the loading sequence and the picking, loading sequence affect the picking process, and it affect the slotting of where you want to put your agricultural product in the warehouse, and do the inventory storage. Okay, and they also use autonomous robot to help do the picking. So this is uh, robot, HIBAH robot. You see this? Okay, they are using this. This is mostly used in EC, like Amazon or something, right? Okay, but they also use it to pick their agricultural product, and they need to make sure the picking sequence is right, because you might have a watermelon, at the last, and some of the vegetable at first, and then they will be compressed. So they need to pick those they are bulky and heavy first, and then put some of the vegetable, deep vegetable above. Yeah, so they need to consider about the sequence as well. Okay. The third is earthquakes. No, agriculture. Okay, earthquakes. Here, because of time, regenerative agriculture. This is the topic we will be talking about. It is to improve the land. With no-till farming, cover cropping, and some of the crop rotation. And in order to restore the soil health and increase the biodiversity, and also improve the water cycling of the soil, it's quite important for the health of the soil. And at the beginning, the productivity will drop, but it's going to come back in 1 or 2 years, yeah. And the idea behind is carbon sequestration in soil. We keep the carbon in the soil, and it was estimated, if the whole world top 40 centimeters of soil can increase their carbon sequestration by just fourth of 1,000 a year, they can balance the carbon emitted by human a year. So trust me, agriculture has strong impact to the greenhouse gas, control, if we do it right. If we don't do it right, it's going to contribute more of the greenhouse. If we do it right, we can absorb it into the soil and even make the soil healthier. So agriculture play a very important role. Okay, so but we need technology to do that. Okay, and right now there are in the whole world there are about 76 million hectares of organic land, and more than are committed to regenerative farming. They are a little bit different. Okay, regenerative farming, you can use some chemicals, no problem, but it had to be in a healthy way. But they look into the soil health. Okay, so multi-layer practices, maturity of the soil biology, some data-driven, etc. And with the practice of regenerative farming in those who committed to do that, we can reduce about 10 to 15% of the greenhouse gas. Believe me, that's a large amount. That's a large amount. And also, we can do some agro forest or polyculture. Put different different agricultural product together. Okay, in one land. When they can be together. Okay, and it's a more natural way of for the environment. It's a more natural way. And let me see. And moving into circular bioeconomy, yeah, and this is a butterfly diagram for circular economy. I'm not get into it, and you might have known this. Okay, yeah, this is an example in Wisconsin. Okay, they have a aquaponics farm. Okay, and first they are raising what we like, the salmon. Okay, okay, in this small pond, and the water in the pond will go to irrigate these vegetables. Okay, they become your salad. So they have two products. One is salad, one is salmon. Yeah. So right now they have 60 acres and they grow like 9 million tons of vegetables. And how much? Yeah, it's equivalent to the 60 acre. The growth amount is about 1,800 acre of traditional farmers. Yeah, yeah. Their yearly income is 10 million. Yeah, it's a lot of money. So they can get the money back in 2 years after the investment. So this is also a very good business. Very good business in Wisconsin. And actually a farm can be a carbon sink. You can absorb a lot of carbon dioxide into the soil. And in this way, you help the environment and also improve the soil health. And there are three kinds of carbon, and the soil carbon is belong to the yellow carbon here. And there are also, when you plant Indonesia, you also have a lot of mountains. So you are also very good at green carbon. And if you preserve the ocean well, you can have a lot of blue carbon as well. Yeah. So in Indonesia, you have a lot of natural resources. You can contribute to the greenhouse gas emissions. And we need to make the resilient of healthy soil. So the regenerative farming is the solution. Okay, we'll do the recall of the two topic, technology and the earth. Yeah, earth fix. Yeah, we combine them together. Try to make it quick. The first is this is an American company. They are using the digital MRV, measurement, reporting, and verification. They use satellite to do that. Okay, satellite. Uh, uh, they can monitor the deep health. Okay, and the coral field of the deep, and to see that if they are mature, if they and also the monitor the soil health to see that when to irrigate, etc. Okay, so they use drones, satellites, images, and AI, to do that. And they need a participant from a lot of farmers, in order to move from traditional farming to regenerative culture. Because at the beginning, they might not have good yield at the beginning because you need to do some not no till farming. At the beginning, you might not have a good yield. But after second time, I think the yield will be back, and the soil become healthier, and you will use less fertilizer, and also you can.
I'm so sorry to disrupting your
Yeah. So how many minutes
material.
more?
Actually, it's
It's
time out,
okay.
but maybe you can have 2 minutes more.
Okay, 5 minutes. Give me 5
Oh,
minutes.
5 minutes. Okay.
Yeah, and they can blah blah blah. Yeah, forgot what to say. Smart cold chain, and also this is the cold chain because after the harvest, I think that the cold chain is important, and a lot of automation can be accompanied. I mentioned about the cold chain in Taiwan. In Indonesia, I heard that most of your fish is consumed in a week after you caught them, right? Most. But in Taiwan, most of the fish is preserved for at least 2 years. Of course, some of them are fresh, but we can preserve the food for 2 years in a deep freeze warehouse, minus 60 degree. Yeah, it's sashimi. Yeah, 2 years later, it's still sashimi. Yeah, you take it back from this deep freeze warehouse. Yeah, you can just have it, serve it, on table. Yeah. Food cold chain. I'm going to skip this. Yeah, these are some of the technology that you can use in cold supply chain. Here, real world case study. The first is IBM Food Trust, and also the MRV is by an American company, Indigo Agriculture. Okay, and yeah, this is the detail of MRV. If you are interested in, they can to use the IoT, satellite, drone, to get all the data. And the farmer, they can join the carbon by their program to generate revenue for the carbon they sequestered. This is the point. Okay, so the farmer join, they can get extra money. Okay, because of the carbon they sequestered, and they get a credit and sell to other companies like TSMC, needed in high demand. No matter how much you need, they will buy that, because Taiwan cannot have enough renewable energy. So many of our companies are buying greenhouse gas credit from other countries in order to sell their product. So this is the big business. So if farmers can follow this, they will make money. Believe me, in order to solve the greenhouse gas problem, we need to keep those who can keep the carbon in the soil or underground some incentive. So if we can give farmer, extra money out of this, it's a plus. They will follow that. If we just say, well, it's good to preserve the earth, say it. We need some action, real incentive. So this company is providing, this incentive to a lot of farmers, and they have said that in 2022 they have 170 farmers in United States are participating in it, and I think there are more. And each farmer in the United States, they have about 100 acres farmland, to cultivate. So it's a lot of that. Yeah, so because of time, I'm think I'm going to stop here, and for later on, for other slide, if you are interested, you can read it yourself. Okay, I'll be open for questions.
Okay, thank you so much, Prof. Tsai, for the insightful and inspiring presentation. Yeah. Now we will open the floor for Q&A and discussion session. We will take 3 questions first, and if the time permits, we will continue with additional questions. So to all participants, feel free to raise your hand and or type your question in the chat box. And before asking your question, please kindly mention your name and institution. Now let's us begin the first question. Yes.
Hello, doctor. My name is Sophia from University of Malaysia, and I do have a very related question with your blockchain technologies. So, basically, my master research is more focused on the food safety, which specific to AMR, antimicrobial resistance, in the livestock system. So, I would like to ask, how can a blockchain technology integrate farm level antibiotics used in like laboratory AMR data to enhance the transparency and the traceability across the supply chains.
Sorry.
Antimicrobial resistant.
Anti.
Yeah, antimicrobial resistant. It's
Okay.
a global growing concern, which highlight from the WHO.
Okay. Okay. Yes, I don't know about this practice.
Okay, it's more to like a bacterial resistant that we can track in our food.
Okay. About the chemicals, residual.
It's more to like a bacterial resistant
Bacteria.
bacteria and the
Okay.
antibiotic use
Okay. Okay.
inside
Okay.
our food.
Yeah, I think that they can trace back to the producer, right? Yeah, and the producer. Can you show me the food chain? The BM food chain. Yeah, and we can ask the producer to be to participate at the food chain, not this one. Yeah, and up, go back. Yeah, and I think that when they register, because it is required they when they use the fertilizer or when they use any anti-medical medicines, in the agricultural product during the production, they will be recorded. And based on the day, they use it, and by your knowledge that how long it's going to decay, right? And they can calculate that. So everything you do will be recorded in a blockchain, so you can trace it back. Is that? Mhm.
This blockchain technology is only applied to the big companies.
No, everybody can participate. You see, sure. You see that the farmers. Well, here. You see how many farmers participate in this system? Growers, 570 million. They are small, independent. Yeah. When you want to sell to others, you join it and you got a subsidy certificate, and you have to follow the regulations that whatever you put during the growing process, you have to record it. And when it is recorded, it is not it is immutable. You cannot change that. Yeah. Blockchain is just a solution that you cannot change the ledger. No. In Taiwan, that our TTAP is if you don't use blockchain, if you want to change that intentionally, you could do that. But blockchain is they make it a blockchain. It means that all the record there, the ledger cannot be changed. The record cannot be changed because it is stored in many places. When there's a change, it will be an alarm. So you cannot do anything afterward. After you have already recorded, it will be there to be chased. And then they can use some analytics to do that, to see that how much are left over in the produce, to improve the safety. Both. The IBM is a private company. You can just participate here. If you're from Malaysia, right? Yeah, if you are country, some of the company, they are interested, they can have their whole supply chain, in this system, and they can have their own traceability system. Okay, yeah. Even in Taiwan, not many are in IBM Food Trust. We saw that is why we have our own T-TAP system. It's by government. Yeah, it's by government. So the government can do that. Yeah, and actually it's not a lot of money. It's just a server. It's just a server. And you can buy the software. It's not difficult. Some of the professor can get a grant, they can write for you. Trust me. The technology is there, not that difficult, not that expensive. The problem is if people will use it. Yeah. And when will people use that? When there's a company asking their farmer, their retailer to follow it, they will follow. Or if the government has some regulation, they will follow. Yeah. So that's the most difficult part, how to really implement it. The technology, the cost is not that much. Trust me, it's not. It has been around for more than 10 years, almost 20 years. Yeah. So the cost has reduced. Yeah, please.
Hi, Doctor.
This is which country?
Australia.
Australia.
Yeah.
Oh, you have the largest agricultural farm in the whole world.
Yeah.
Okay.
I have a question about regenerative farming.
Okay.
You mentioned earlier that when switching to regenerative farming, the yield might be less to begin with,
Yeah.
but then it will return.
Yeah.
We've had other presentations this week that have still shown that having synthetic fertilizers still have significantly larger yield.
Okay. Beginning.
At the beginning, but this week we haven't been shown the return. Like there's
Okay.
no proof around that.
Okay. Okay.
At least in my knowledge and what we've received from researchers. Do you propose that farmers should rely on the carbon credit system as a compensation for
Yeah.
this loss in income? And is this like enough of an incentive? Like, is this above what they're already receiving? Because obviously they need some sort of like motive to join this.
Right.
Yeah.
Right. Yeah, that's what I mean. Yeah, if they can generate some revenue out of the carbon they sequester. But, in order to do that, you need to join a system. It's not saying that, oh, I'm doing the, regenerative farming and I will make money. No. You have to participate. So that what I mentioned, the Indigo Agricultural Company of the United States, I think that for your country, you can have their company, no problem. The technology is there. So but they have to get into a system. So they know that how much carbon is sequestered. So they know that because the data will show that for this farm. So they can give how much money to this farmer. Yeah. Yeah. So
Sorry, what was the system that they need to join?
yeah, let me see.
Of the Indigo. Yeah. Okay.
Yeah, it's the company they join. It's not the company, but the company can help you get the carbon credit. Yeah, they join the International Carbon Credit Association. Yeah, but I don't think that a single farmer can do that. They need an organization to do that. Yeah, they can either join the company or they can have a co-op system. When many join together, there's some fund they can get a credit from it. Yeah. And for this credit, it's also very IT oriented because they need proof. They need proof. Yeah. Other questions?
Prof. Tsai, actually, we have a question from a chat box.
Okay.
Yeah, it's from Akmal from Computer Engineering. And Professor, I have a question regarding applying automation in agricultural. Uh, yes, you can read that.
Okay. Non-control environment. Well, you know, this is not only a question from agriculture area, it's also a question from other industry as well. You know, in the past we have automation first, and then right now the intelligence, and then combine them together, we call it the autonomous. Okay, and it's intelligence plus automation altogether, and you know, not really that we need to move to automation. When we need automation, actually, it's in countries that you have a labor shortage. Trust me, you know, labor shortage. I've been to like Germany, you know, their largest retailer, in their cold warehouses, it's all automation. And I asked them, but have you ever counted the return, you know, rate of return ROI? They say, well, it's not an issue because they can not have enough labor. So in order for the business to run, even though they are losing money, they had to invest in the fully automated warehouse system. It cost them a lot of investment. Yeah. So right now, automation is the problem. And right now, you said that when we have digitalization, of course, digitalization is much cheaper compared to automation. Yeah. And so for some of the country who haven't yet have automation, you know, if digitalization can help you, uh, you can just do that. And then I think that the ROI from investing in digitalization could be higher, depending on your application. So I'm not saying that everyone should go to automation. It costs a lot of money. Yeah, depends. Okay.
Hello, good morning, and thank you for the presentation,
Mhm.
Doc. I'm just wondering, okay, I understand that we need to reduce the carbon emission, so all those uh strategies presented are good. So I'm just wondering that using AI, we cannot avoid using AI because of the digitalization, but the AI system requires a lot of fresh water to cool down the system. So knowing that, are there in the industry of the AI and in your expert opinion, are there or knowledge, are there any alternative ways they are doing right now to somehow avoid too much use of fresh water?
You know, for the AI, fresh water is one of them. You know, the largest harm is they need a lot of electricity.
Mm.
Yeah, electricity will create even more problem. You know, for a 3 data center is you know, someone give me an example. 3 data center is equivalent to I forget how many million of city electricity usage. So that is the main problem. You know, to cool it down, you need water, but the water can be recycled, okay, circular. And also, if we so you know, someone said that why Trump won the Greenland? Is it because he want to set up a lot of you know, data center there? There is nature cooling system there. So the cooling is a serious problem, but I think it's still acceptable. water is not that critical, but electricity. Yeah, electricity. Yeah. But in some way, we still need it because it really helps us.
Okay, thank
You
you.
know, many of the slides today was suggested by AI. And of course, I modified it. Yeah. Any other question?
Prof. Tsai,
Yeah.
there's a question on the chat box
Okay.
from Jefferson. Is technology like this can also be used in far-flung area like mountainous area? And are there mountainous places today that are currently using this technology?
Yeah. As I mentioned at some of the beginning, we talk about the digital divide, infrastructure divide. So that is the obstacle, the gaps for this ideal system. But you may want to try to solve this problem by like a Wi-Fi. If I think that in the future, satellite Wi-Fi will be there, and also you can use some drones, to help you do the monitoring. So I think it is still possible. It is still possible. Yeah, but you can plan it peculiarly. Yeah.
Okay. Anyone have another question? Okay, Puput.
Hello, sir. Thank you for your
So which
presentation.
country are you from?
I'm from Indonesia.
Oh, this is your symbol? Only red? Really?
Yeah.
Oh, sorry.
The
That's
flag.
right, because the background. Okay, okay. Sorry. Okay.
My question is about you said it before that there should be a supply demand coordination
Yeah.
to avoid the food loss, right?
Yeah.
And it can be seen from the sales before to expect the next demand.
Yeah.
And next supply. And how what happen if it's not as set predicted?
Is
Like for example, if the sales, for example, a 100 and it's expected like 100 also in the next month, for example, but the reality is not like that. Like it can be more or less.
Yeah,
And
sure.
like how to overcome this problem, and is it happening in Taiwan too? And yeah, how to overcome this? Thank you.
Yeah, how to overcome this problem? Yeah, the problem with forecast is don't trust forecast too much. You never be accurate. But why people are talking about forecasting, especially using a lot of AI? We invest AI for the forecast because if we do not have a forecast, we don't know what to do at all. But don't trust it too much that this is, oh, okay, next month I'm going to have 10 million of revenue. No, it's fluctuated, but it's an estimate there. So everything is an estimate. There will be some fluctuation, variant, volatility, but if you have a rough figure, it's always better than nothing. Yeah. So, and the second question is if it happened in Taiwan. Yeah, it happened all the time, everywhere. Yeah, for this, so I said that only for this system, this particular example, so I have this example, so I can say that. So they can control it. So their loss is much less compared to others, and they have a better price, more stable price for the consumers. Yeah. But as I mentioned in the beginning, our cabbage balance system by the government failed. Yeah, farmers don't get this. Yeah, they just at the end they complain to the government. Why you don't tell us? Why didn't tell us? But I've already told you. But you just want to do that. Yeah. Yeah. Some other
Thank
question?
you.
Okay, maybe one last question, anyone? We still have 4 minutes. Yes?
Good day, Doctor.
Yeah.
So, regarding cold supply chain, the problem I see here is that the cold supply chain uses a lot of energy.
Yeah.
And how do you
Justify.
yeah, and is hydrogen as an alternative for energy feasible for the cold supply chain?
Hydrogen.
Yes, I've seen articles of cars using hydrogen as
Yeah.
the power. Can
Yeah.
it also be applied here?
How to say that? Hydrogen and the coal supply chain is irrelevant topics. Hydrogen can be used as a power source, no problem. And the power source can be can use to generate the code. Yeah, to make the machine run and to generate the code. So, but hydrogen is, I believe hydrogen will be the next power source. Yeah, I don't trust battery too much, but I believe the hydrogen can be a better solution for that. Yeah, in the future, in the years to come. And the first question is about cold chain use a lot of energies. Yes, but in the meantime, it also preserve much more food and make the supply and demand more stable. Because when you have too much production, you can keep it in the warehouse. They have cold warehouse and frozen warehouses. So depending on the produce, okay, and so you can try to balance the demand and the supply. So when the market need more, you can release it to balance the price. Yeah, that's all government are usually doing. Yeah, because Taiwan, a lot of environmental problems, so the yield rate is not that stable. Yeah, not that stable. Yeah, one last
Okay.
question? Oh, okay, great. Oh, okay. I believe the hydrogen, yeah, I believe hydrogen. And cold chain, many people have that question in mind. Yeah, so by using cold chain, I think that the benefit would be much more than the energy you can consume. Yeah, and you might not know this, that for the cold chain, for like our air conditioning or the freezer, the energy efficiency, do you know how much? Many talk about percentage, but not in this area. In the air conditioning, in the cold chain is how many times? So you have 1 kilowatt of input, you can generate in the normal machine like this air conditioning, you can generate 3 times of cold. Yeah, it's an exchange. It's an exchange of because you expel the heat outside, so you leave the cold inside. So and for industry machine, you can generate from 6 to 20 times. So you can 1 kilowatt of electricity, you can generate maximum like a 20 kilowatt of cold to the warehouse. So it's not energy consumption machine. It's a very good cycle. Yeah, it's a multiplication. It's not against any physical law. It's just to switch the energy outside, the heat to outside. So right now they also a heat pump. You don't need. We also need heat pump here. Heat pump will +1. The energy efficiency is after the coal you +1. So it's quite efficient. Yeah. So the cold chain, if you have a good system, it's not losing a lot of money. It won't cost you a lot of money and not using a lot of electricity. Yeah.
Yeah.
Okay.
Okay, Prof. Tsai. Unfortunately, the time is up.
Yeah, we are in that time.
Yeah.
Yeah, and thank you. At the end, we have some slide. I do not have time to present. I thought that I had more time, but yeah, it's my pleasure to share with you. And many of you are smart and bright. And thank you. Okay, thank you.
Okay, unfortunately, we need to conclude this discussion. Thank you so much, Prof. Tsai, for your thoughtful answer and most importantly, for sharing your knowledge. So before we close, please allow me to briefly summarize today's session. Today's presentation highlights the importance of transforming global agri-food supply chain by combining digital technology with nature-based strategy. We learned that the current food system faces major challenges such as an environmental problem, food waste, and supply chain disruption. In response, digital tools like IoT, blockchain, and AI can improve efficiency, transparency, traceability, and decision making across the supply chain. At the same time, nature-based approach such as regenerative agriculture, agroforestry, and soil health management are essential to build a more resilient and sustainable food system. And overall, the session show us that the future of sustainable agri-food supply chain lies in the integration of technology and ecology. Once again, thank you very much, Prof. Tsai, for the excellent presentation and for being with us in a short course session. And with that, we have come to the end of the session. I would now like to hand this session back to the Master of Ceremony. For the next agenda, I'm Intan Dewi Larasati, your moderator for this session. Thank you very much and have a great day, everyone.
Thank you so much to Professor Kune-muh for being an insightful lecture about digitalization and nature-based strategies for sustainable global agri-food supply chain system. We would like to give the appreciation certificate that will be given symbolized by our moderator.
A souvenir for you.
Okay. Thank you.
And also, we would like to thank Ms. Intan Dewi Larasati, who led the discussion before, and the certificate of appreciation will be given by the chairman of Short Course 2026, Dr. Rizky Maftuhah, MSc. Okay, may we give applause to the speaker and the moderator? Okay, with the session of appreciation certificate already implemented, then the second material of this short course has ended. For operator, you may stop the recording.